Hello again, and this is Kurt Knox with Emmy Kim and Katie Erling. We are starting Chapter 2, Section 1, Using Light. And as always, you guys should have already read the section, pages 38 through 45. This is about waves and the electromagnetic spectrum. All right, in this video, after you're done watching it, you will know about the waves and their property, and you should know about the electromagnetic spectrum and what makes it up. All right, waves and energy. What is a wave? Well, a wave is anything that transfers energy from place to place. Think of a seismic wave, an ocean wave, a sound wave, or a light wave. It transfers energy from place to place. For example, sound waves, if you've ever been stopped at a stoplight and you hear this loud music coming from the car next door, you know that your mirrors shake because that music transferred that energy and caused your mirrors to shake. So a wave is anything that transfers energy from place to place. So what carries waves? Mechanical waves are carried by a medium, such as a gas or a liquid or a solid. You are hearing my voice because my voice shakes the air or the gas around your ear, and it causes your eardrums to vibrate. If you've ever been in a swimming pool and you cracked your knuckles under the swimming pool, you could hear your knuckles crack because the sound travels through liquid very well. And a solid, if you put your head against your desk, tap the table, you can definitely hear the tap. So mechanical waves travel very well through a medium. Electromagnetic waves, however, do not require a medium. Electromagnetic waves are light, radio waves, things like that. Mechanical waves, though, are things like seismic waves, ocean waves, and sound waves. So, how do waves transfer energy? They transfer energy through vibrations. And again, a seismic wave starts at an epicenter and it vibrates the earth and it radiates out. Okay, a sound wave starts in your voice or vocal cords and it vibrates the air and it vibrates out. So waves transfer energy through vibrations.
Okay, let's take a look at a wave and look at the different properties of waves. Okay, this imaginary line that goes through the middle of the wave is called a rest position, and the distance from the rest position either to the top of the wave or to the bottom is called its amplitude. The distance of the highest point on a wave is called a crest, and the lowest point on a wave is called a trough, and the distance between either two corresponding crests or two corresponding troughs are called wavelengths. Frequency is the number of times the wave go up and down in a certain amount of time. So let's say that this was 1 second. You can see that in the same amount of time, this one up here has gone up and down a lot more than the bottom wave, and so we would say that it has a higher frequency and this one has a lower frequency. The wavelength, however, is shorter on the top wave and it's a lot longer on the bottom wave. Now, which do you think carries more energy? Well, if you and a friend held the end of a jump rope and one of you did a slow wave like this one, and then did a fast one like this, which one do you think they would feel more energy from? If you pick the first one, you would be correct. Frequency is measured in hertz. Speed is how far the wave travels in a certain amount of time, and you can calculate speed by multiplying the wavelength and frequency together. You can increase the speed of the wave by either increasing the frequency or the wavelength or both.
So electromagnetic waves. The energy transferred through space by electromagnetic waves is called electromagnetic radiation. And if you remember, when Mr. Knox was talking earlier, he told you that mechanical waves need a medium to travel through. Electromagnetic waves do not need a medium. So, a medium would be something like water or air. Electromagnetic waves don't need that. They travel through space without it. All electromagnetic waves travel at the speed of light, which is 300,000 kilometers per second. To give you some point of reference, light from the sun takes about 8 minutes to travel to Earth. What is the electromagnetic spectrum? Well, we know that it is made up of electromagnetic waves. The complete range of electromagnetic waves placed in order of increasing frequency. So you can see over here on the left we have radio waves, TV waves, microwaves, and the frequency of the wave starts to get closer and tighter together. So over here we have a lower frequency, and over here we have a higher frequency. This tiny little part right here is the spectrum of visible light, which is just one part of the electromagnetic spectrum. This is the only part of the electromagnetic spectrum that we can see. Radio waves, like we talked about in the last slide, are the longest wavelengths, the lowest frequencies, and things like AM and FM frequencies, television and police radar guns use radio waves. Microwaves are shorter. They're over here. They have shorter wavelengths, higher frequencies, and things like ovens and cell phones use microwaves. Infrared rays over here are used in heat lamps. So if you've ever been sitting out on the patio of a restaurant at night and you felt a heat lamp, those were infrared rays. Visible light is made up of different colors. The main colors are red, orange, yellow, green, blue, indigo, and violet. The largest wavelengths over here on the left, starting with red all the way over to the smallest wavelength, indigo violet. Ultraviolet rays are from the sunlight, so if you've ever spent too much time outside and gotten a sunburn, those are from ultraviolet rays. X-rays, the wavelengths are just shorter than the ultraviolet, so that they can pass through most matter. Gamma rays, the shortest wavelengths, highest frequency, most energy, and gamma rays can be used to kill cancer cells in the body. So radiation is one type of cancer treatment, and they use gamma rays. So pause the video, see if you can come up with a quick way to remember the order of the electromagnetic spectrum by making words from the first letter of each type of wave. So over here we have radio waves, microwaves, infrared waves, and so on and so forth. So pause it, stop and think about it. Hopefully you paused, came up with something, because this is a great tool to help you study. One that Mrs. Kim told me is racers must increase velocity using extra gas, and this will help you remember the waves across the electromagnetic spectrum.
Wait a second.